Um, I did research with Professor Liz McCullough from Oklahoma State University, and we focused on the effects of estrogen and cognitive decline in Alzheimer's disease using mice models. Um, so, just an overview of Alzheimer's disease. It's a progressive neurodegenerative disorder, and it affects over 50 million people worldwide. It causes a gradual decline in memory, learning, and decision making as age goes on. It's the most common form of dementia, and the exact cause and cure still remain unknown, but treatments and medications do exist. So, I focused on the implications of estrogen, which is a female hormone in the female reproductive system. It's a hormone that's produced by the ovaries, and the hormone supports brain health, neurogenesis, and inflammation control. Studies have suggested that estrogen disease after menopause is a key risk factor for Alzheimer's disease. Uh, so, for our method, we use the Morris water maze, which is a commonly used test with mice that uses spatial learning and memory of the rodents. It's widely used and it's been proven to be reliable in assessing hippocampal function. Um, the setup is a large circular pool filled with like opaque water, and there's a hidden platform submerged just below the surface. There are also visual cues placed around the room for navigation for the mice. Oh, shoot, sorry. The objective is to assess the spatial learning and memory in the mice under different hormonal conditions. And in this case, our conditions were sham, which were the mice with the ovaries intact. So they did have estrogen, and overactimized mice, estrogen depleted mice, since their ovaries were removed. The training then occurred for 5 days, and the mice were undergoing 4 trials a day. So there were 20 trials total. I only analyzed videos from this because obviously I live in Connecticut, so there's no way I could be in the lab. So videos were taken in the lab, and then I would use this platform called AnyMaze to analyze like the behavior of the mice in the Morris water maze. Uh, the goal of the mice was to learn the location of the hidden platform under the water. We measured time to find the platform, and we found that time to find the platform should decrease with learning. So as the days go on, it should take a less amount of time for the mice to find the platform. Let's see. This is just an example of the mice in the water. So they're placed in like the circular pool, and they just kind of swim around until they find it. For results, on the y-axis was test duration, which was the time that the mice was placed into the water until it finds the platform. This analysis was conducted by me, so I manually like stopped and started the timer. And then the x-axis here are trial numbers. So there were 1 trial from each of the 5 days. And then as you can see, like on the graph, as the time went on, it seemed like the mice took a shorter amount of time to find the platform, which represents the learning curve. Uh, for analysis, there was a significant finding, and it means that something like on day 5 affected the mouse to give us significantly different values, though we don't really know what it was since was the treatment was implemented in a small like sample size, so it's not really like generalizable. On the probe trial, day 6, that was when the platform was taken away, and it was just to see if the mice would behave differently, like looking for the platform, or it would just realize it wasn't there. It took a little longer for the mice to enter the platform zone in this case, mainly because it was probably confused that they couldn't find the platform on the 6th day, where they were used to it by now. Um, Yeah, a two sample t-test was performed using AnyMaze. The platform gave us a bunch of statistics after I uploaded all the videos and then timed the mice manually. But there weren't any significant findings for the probe trial since the p-value was greater than 0.05. There just could be that there weren't enough trials or data for like the randomness to be kind of evened out. So, while the number of trials were limited, the trends do suggest that estrogen status has an impact on spatial learning and memory on these mice. During training days 1 through 5, both the OVX and sham mice showed learning over time, but the sham mice, the ones with estrogen generally performed a little bit faster in the later trials, finding the platform faster, which could suggest improved memory. But again, since it was such a short experiment with small sample sizes, we can't really generalize that. In the day 6 probe trial with no platform, the sham mice made more entries onto the platform zone, but they did have shorter latencies. It took them a little bit like shorter time to find the platform, so it could indicate a better recall of the location of the platform. And then just based on qualitative observations when I was watching the videos, it seemed like the overreactimized mice showed less confidence when they were exploring. They kind of just lingered in one spot or the other, which may indicate that estrogen loss is linked to impaired cognition of these mice. But overall, these findings could suggest that estrogen has a protective role in memory, and that the mice without estrogen could reflect aspects of Alzheimer's related decline for women after menopause. Uh, Again, limitations include a small sample size, remote only analysis, and then restriction to the final trials of each day only. I'd like to thank Professor McCullough from Oklahoma State University and the lab there that helped me coordinate this collaboration and make this analysis possible. And a PhD student, Jessie Hurd, who really helped me out with her guidance and how to use AnyMaze. I'd also like to thank Talaria Summer Institute for like giving me this opportunity to conduct high school research and making it possible. And they were just references, and yeah, that's all.